Assistant Professor of Unconventional Energy Sources and Electrical Engineering at Dr. PDK Akola. He is also working as a research engineer on AICRP on EAAI at Dr. PDK Akola. Dr. Khambalka sir is having more than 15 years of research and teaching experience in the field of agriculture engineering. His area of research focused on farm machinery and renewable energy technologies. In his contribution, he developed farm machineries like BBF planter. He is editor of various journals of the international repute. Sir is also recipient of the prestigious awards like Institution of India Young Engineer Award 2012 and many more. Besides this, he is one of the founder director of PDKV Research and Incubation Center. So today we are fortunate that Sir has joined us for this session. Today, Sir will deliver on the topic challenges in adoption of renewable energy system, a scientific scenario in 2050. So on behalf of the NHEP, I welcome you, sir, for this session, and now I hand over this session to you.
Thank you, Swati. Good afternoon to everyone. Screen Ali, show?
Yes, sir, it is visible.
Okay, today topic given to me by the organizer is the challenges in adoption of renewable energy system, a future scenario. So here the energy path for the primary energy sources to the energy service I have been narrated here. It is being adopted from the International Energy Agency. So primary energy sources is there, energy carriers is there, conversion type is there, usable energy flow is there, and how the energy is being utilized as an energy service. So the nuclear fission, fossil fuels, bioenergy, geothermal energy, direct solar energy, wind energy, hydropower, and ocean energy. These are the primary energy sources we have generally categorized into a conventional and non-conventional energy sources. So they are the intermediate fuels which generally we are using as a liquid fuel, solid fuel, gaseous fuel, or combinedly as a electricity by using the various sources. So they have been converted through a thermal conversions method or the kinetic conversion method. So we may use the energy as a direct as a work, or maybe converted into heat, or based on their services, we may utilize the energy as a heat-based energy service, direct and heating of lightning services, electrical energy services, and mechanical energy services. These are the very simplified scenario of various energy sources which is being generally utilized worldwide for the conventional and the non-conventional sources. So here again one slide is there for the employment in renewable energy by technology selected. So based on the technology, which energy sources have a predominant share in the employment. So we have narrated here the biomass, solar thermal, wind, solar PV, then hydropower and geothermal. This table has been adopted from the UNEP, United Nations Environmental Program. So China, basically China is the China have a major employment generation through the renewable energy in worldwide scenario, and India lacking behind. That is, it is at last stage, 7 number. So China basically looking for the solar energy and the biomass. So even though we are the agricultural country and produces the agro residue, but we are lacking behind to generate the employment through the renewable energy in our Indian scenario. So basically topic is for the challenges in adoption of renewable energy. So we are looking how to value the product. That means the value chain is there for the various renewable energy sources. In these presentations, I have taken the solar energy, biomass, and the wind energy. These are the major source of energy in our country. So value chains, what are their major elements? So equipment manufacturing and distribution, this was the major component where we have a futuristic scenario to make the value chain as stronger in our country, so that the employment has been generated strongly. Then project development stage, construction and installation, operation and maintenance. These are the four major elements of the value chains in the renewable energy. For the various resources like the solar, wind, biomass, geothermal, and hydro. The bioenergy sector has a fifth major element to its value chain is growth, transport, and processing of biomass. This one is the major sector in the bioenergy that we may have to add in a value chain for the growth. That's means the growing stage of the biomass, then transportation and the processing of biomass. These are the fifth elements of the value chains in the renewable energy. So the this one is the simplified figure how to value chains from equipment manufacturing to the operation and maintenance. It is being diverted. So first, wind value chain, that is the wind energy value chain, how it is being implemented. And here we have a occupational trust area where we are lacking in India. But in overall scenario, it is being observed that in equipment manufacturing and distributions, R&D is the major component where the material R&D of that particular technology is being observed. Then component design and manufacturing. In wind energy, we have example of blade, towers, nacelle, generator. Then modeling and testing, that is the prototype development and their testing. Raw material supply, assembly, quality assurance, certification, marketing, sales, and delivery. This one is the one case of the equipment manufacturers and distributions in the wind energy value chains. Once it is being covered, then we will see here the project development stage of the wind value chain. That is how the wind farm we have to design according to the resources. Then wind resources assessment. This is the one stage where we have value chains opportunity. Environmental and social assessment. That is the birds, visibility, water, etc. We have to maintain the concerns about the environment while implementing the such type of project. Then land agreement. This one is the very important issues while we are implementing the wind energy project. Then economics and financing sector, this one is the major component in value chain of the wind energy. Then permit applications, monitoring, and any amendment is there. Then power purchase agreement. PPA agreement is a very PPA agreement in India is a very complicated issue, and according to the state, it has been changed. Various policies there. In Maharashtra, we have MERC. MERC generally regulates the power purchase agreement. Then grid connection strategies there and selection of the suppliers. Who is going to select, who is going to supply the particular product for the project development. Then another chain, that is the value chain of wind, is the construction and installation. This is a very important phase where the infrastructure we have to be developed. Then turbine erections and their installation and grid connection. These are the issues, and here we have opportunity to make the sense of occupations in the renewable energy. Then operation and maintenance element in the value chain, that is the operation and maintenance strategy. We have a seasonal, monthly, and annual operations we generally observe in the wind energy projects, financial management, and a repowering or removal. These are the cases. Then cross-cutting enabled activity, that is the training we needed for the operation, for the efficient operation of the project. Policy making issues is there, management and administration issues, insurance, IT, health and safety, financing, and communications. These are the various component sub-elements of the wind value chain while implementing the projects. Then similar way, we have narrated here the solar value chain. That is initially we have seen the wind energy. Now it is being solar energy value chain. Same prototype I have been narrated here, that is equipment manufacturers and distributions. Definitely R&D, designs, modeling, testing, quality assurance, and quality control, marketing, sales, and delivery. This one is the one issue. The second one is the project development. Similar way I have narrated the solar system or farm design, site assessment, then environmental problems and social impact, land agreement, economics and financing. Permitting is there for some projects, permitting we needed. Power purchase agreement, this is critical issues in our country, and selection of the suppliers, who is going to supply. So this one is the solar value chains. We have seen the project development aspect or element. Then construction and installation. This one is a very important issue in the uh, solar plant implementation. Then construction of solar system farms, solar panels, their installation, quality assurance, and quality control, grid connections. These are the issues we have observed generally in construction and installation. Operation and maintenance strategy element. The annual operations, monthly operations, daily operations and maintenance have been leveraged with the system and recycling issues. Then cross-cutting activities with training is very important. Policy making, management, insurance, IT, health, safety, financing, and communications. So this one is the solar value chain we have presented here. Now we are looking to the biomass value chain. So before that, we have an example how biomass has been converted into a various product. So feedstock, it has been mentioned here, that is agricultural waste, animal waste, forestry waste, industry waste, municipal waste, sewage, crops, and other feedstock is there. So based on that, it has been categorized, that is the solid biomass, oil crops, sugar crops, and wet biomass. So based on the characteristics of that biomass particular, we have their process, how the raw material have been converted into an end product by using some process. Combustions we have, gasification we have, pyrolysis for the solid biomass. For oil crops, it is the extraction, that is extraction of oil. We will get the biodiesel. Then for sugar crops, fermentation process is there. We have ethanol by making the steam distillation. And it is being, again, we have used the reformer hydrogen, we'll get the hydrogens, biogas. In wet biomass, we have anaerobic digestions, we'll get the biogas. And here is the product we will get by using the various feedstock, various process, intermediate process also, and the product is heat and power, methanol, FT conversions, biodiesels, ethanol, reformer, and hydrogens. So this one is a very simplified process of biomass conversion into a various value-added product. So based on that, we have a bioenergy value chain. So again, we are at here. Why I am narrating here the value chains? Value chains means in Indian scenario, we generally not we generally not look at the skill development or the capacity development in the various sectors which are essentially required for the commercialization of the project. That is for the particular elements. In bioenergy, we have equipment, manufacture, and distributions. So R&D is needed. Suppose we have considered the one project, that is the biogas, to generate the energy, that is the power from the biogas plant. So R&D is very important. How the biogas is, how to install the biogas, what is their design features, their digester, refineries, components, we have to be designed. Then we have to make the quality assurance, marketing their sales and delivery. This one is the one component we have narrated in a elements of equipments and manufacturing distributions of value chains. Then project development is there, their designs, how to design the project, how we have to be resource assessment, their environmental impact and social assessment, financing stages, they're very important, land agreement, permitting, and selection of the supplier. So the subcomponents of every value chains in wind, solar, and bioenergy, they are similar, but according to their particular element, that is construction, operations, here the biomass production is the very one new element we have been added here. That is the cultivation, harvesting, and transportation. This one is the fifth element of value addition chain of bioenergy. Then cross-cutting activities we needed. That is the training is important to understand the value chains of bioenergy for the proper sustaining. Then policy making, management and administrations, insurance, IT, health and safety, financing, communications. Biopower transmission is the issue and their distribution. Generally, such type of project are the decentralized project. So we have to make the proper care how the project have to be connected to the grid, and their major issues there while connecting the project to the grid. So here again, I have narrated here the total technical bioenergy production. Particularly, I have concentrated on the bioenergy. That is our sector is agriculture, and agriculture is the very important sector where the agro residues is generated. So 2050 scenario is there. So in this scenario, China, that is the East Asia and India, the potential is given. But India is very much lagging. We do not have a surplus of forest waste in India, but we have a agriculture and forestry waste and residues. So we have potential in that particular uh, waste to harvest that agriculture waste in energy. Then dedicated woody bioenergy crops in some areas, some pockets, the bioenergy crops is going to be cultivated if there is a surplus of land. So again, the issues we have, that is occupational difficult to fill, means when we are implementing the project, we are facing the problem of skilled workers, technicians, then engineers also. So in Indian scenario, the occupational difficult to fill in relation to the skill and capacity of renewable energy for the particular subsector, that is wind energy, solar energy, hydropower, geothermal and bioenergy. So the occupationals are project developers. We are lagging for the project developers skill, service technicians, data analyzer, then electrical, computer, mechanical, and construction engineers. So we are facing the problems. Then solar energy, that is a photovoltaic and solar thermal system installer. Their maintenance systems, building inspectors. In hydropower, that is electrical and operation and maintenance engineer, technicians. In geothermal, that is the trainers of geothermal engineers. India is lacking in geothermal. Bioenergy, R&D, we have a very few R&D institution in India. There are design engineers, particular bioenergy design engineers we are lacking. Then service providers and technicians. So these are the occupational difficult in relation to the skill for adopting the various resources. We have mentioned here the wind energy, solar energy, hydro energy, geothermal and bioenergy. So we have to take the concentration on the occupational skill in major subsector. So again, one thing I have mentioned here, that is the average employment over the life of facility. So the sector mentioned here is the solar, wind, biomass, coal, and natural gas. So based on that sector, how much employment generations, that is the jobs per megawatt of average capacity. So in solar photovoltaic, we have a in manufacturing sector, construction and installation, 5.76 to 6.21. This data table I have been adopted from the International Energy Agency. This one is the worldwide scenario. So the solar photovoltaic is the major employment generating source per megawatt capacity. Then later on for the manufacturing and construction, later on the wind is there, 0.43 to 2.51. Biomass there, coal fire is there. That is the natural resources. That is the solar is the very important sector where we can generate the employment.
Participants are requested to wait for a few minutes as there is power failure.
Shahu?
Yes, sir, your screen is visible. You can
Okay,
start.
okay. Uh, so, sorry for the interrupt. The grid is not available. So we are talking about the grid and the employment and the power resources. So this slide shows the average employment over the life of the facility. That is jobs per megawatt of average capacity. And in Indian scenario, why we are thinking for the renewable energy, this one is a very important uh, task for the government that need to generate the powers from the renewables, and simultaneously they can help, such a system can help for the more jobs per megawatt. So the government of India also thinking for this type of orientations to generate the employment by adopting this such power sources. So this one is the one energy data and their statistics. So as of March of this last year, 35% of the energy installed is generated from the renewables. And once we have, it is being with the utility, it is being 22%. In India, the renewable energy sector is the second most attractive renewable energy market in the world. So, there is a reason that the cost, land, then PPA agreement, the most policies government is adopting is user friendly and market friendly, and which attract the peoples to invest in the renewable sectors. So with the grid connected renewable electrical capacity, it is being 84 gigawatt we have reached, at which the solar photovoltaic is 32 gigawatts and 37 gigawatts from the wind energy. So remaining from the small hydro, solar PV. Solar PV means the system and the biomass. Again, one scenario is there, that is installed grid interactive renewable powers. So major source is contributing from the wind power, it is 42. Solar is 40, biomass is there. So we have a chance in biomass power to develop the value chains from growing of biomass to the installation of the product by using the various elements of value chains. This is the very important sector for agriculture and forestry also, that we may involve in the biomass power generations. Then again scenario here is installed grid power capacity overall sources, that is from traditional and non-traditional sources, and coal is playing the major role. After that we have a renewable energy. It is being near about 24% of share of power generation came from the renewable power in India. We have initially seen this, that is the non-renewable and renewable sources. So energy consumption patterns in our country, it is being depicted from 1973 to 2017. So initially industry sector consumed the less energy, but as day by day, our industrialization process involved the consumption of energy, and now it is a very big sector, requires the more energy. So then residential, initially it was being second major component where the energy consumption we have. In initial phases, it is a very major component, that is the residential consumption of energy, but it is now the second one component which consumes the energy. So energy productions and their self-sufficiency. So for the Indian scenario, there is the coal and biomass are the major sources major sources of energy in Indian context, and to replace the coal in many cases, the government of India has started the biomass power generations projects. Then again, the project on the west also provide the solutions to the coals. Indian oil and gas production is relatively low, so that the country depends on the imports of coals and the oils. It is being generated from the Australia. We are importing the coals. Domestic production has not kept up with increased energy demand, and India remains dependent on energy imports, especially in the oils. So these are the scenario where we have to diversify our source of energy to the renewable energy. So some environmental effects of fossil fuels-based power plants. So they are having impacts. The power companies use a variety of process to create the electricity. The process they are using is creating the pollutions, the effects on the environment in many ways. The coal is a much more environmental problematic source of energy. Then greenhouse, this one is the very important issue. While adopting the traditional power sources or using the traditional fuels, most mechanism for generating electricity releases the carbon, and which impacted on the greenhouse gas. So in renewable cases, there is a minimum chances to generate to create the greenhouse gas. Pollutions is a very important issue. That is a traditional power plants of the oils which generate the electricity, which also generate the waste. This waste, hazardous waste, impacted on the environmental quality, and we have to make the concern. This quality day by day is environmental pollution is day by day increasing, and the renewable sources makes the environment clean environment energy productions. Then waste disposal, we have challenges in thermal power system. Whatever the waste is being generating, the disposal challenges in Indian scenario, and injuries to the wildlife. Both the generations and delivery of the electricity can harm the local wildlife. These are the grid connection issue at the national level. Birds may be flying into the power lines, resulting in electrocutions. Then in wind farm also the such type of issues, but the some wind shelters protect the birds. Then again we have a scenario of renewable energy supply and demand trade. So the share of renewable energy in India is increasing day by day. Last decade it has been fallen, but some policies has increased the energy generations from the solar photovoltaic and the wind energy, and now India is ranking at the top fifth country in global scenario to harvest the renewable energy from the natural sources. So there is one trend of renewable energy and waste. So it is being from 1973 to 2017. solar, wind, hydro, biofuels, waste, and renewable and waste shares is at right axis. So biofuels since from the independence up. So we have majorly concerns on the biofuels and their waste. And the agriculture is the one major sector where we get the biofuels as a agro residues, various agro processing waste we have. So there may be a chance to convert that into electricity. In this scenario, it is being generally cooking applications of bioenergy is being included so that the scenario is looking larger. So this one is the last 5 years, we have a rooftop solar PV system is emerging as a source for the individual grid at homes, then offices, buildings, for the residential and commercial purpose. And so the solar PV applications we have, and Government of India has set up the friendly policy to the Indian scenario. We generate the energy as an individual grid, and the target set by the government is 40 gigawatt for the rooftop, and it is being achieved. We have to achieve in 2022. The MNRE has adopted guidelines for the implementation of phase 2 of grid connected rooftop program. The target is supported by the renewable purchase obligations, rooftop auctions, and program that facilitate the deployment of rooftop solar PV system in government buildings across the country. Then we have another major source of energy in India, that is the offshore wind. The government estimate the potential of offshore wind to be a region of 10 to 20 gigawatts. It is dependent on the wind, that is how the wind side is there, and based on that, we have a wind potential. A good alternative onshore wind, offshore wind, however, has to be adopted in India. And initially the government has tendered it for the 1 gigawatt, but with the collaboration with the European Union to identify the bottlenecks in the supply chain. Supply chains means here initially we have discussed the value chains and the industry infrastructure. We are lacking in the such type of cases. Then upgrade PV system, that is this system launched by the Government of India. So in some programs I have been mentioned here. In 2017, it is upgrade and decentralized solar PV power program. In 2018, it is Atal Jyoti Yojana, phase 2 program. And in 2019, it is a Kusum scheme. It is particular for the farmers, that is the PV farming, solar farming, generally known as. So again, bioenergy and their waste. So now we are at the barriers. What barriers and challenges we have while implementing the renewable energy technology in our context. So political and regulatory barriers, technical issues is there, social and cultural issues, financial and economic, market related barriers is there, geographical and ecological barriers, and informational barrier. These are the very list out barriers in India. So political, not a to develop the renewable energy systems in India. Policies and regulations favoring the development of renewable energy technologies can hinder the adoption of these technologies. Then additionally, is low, so that we are lacking in the investment. Therefore, because of the large scale renewable energy projects requires large amount of capital to run the project, many countries progress toward the renewable energy is held back by the policymakers, failures to implement the measures to attract the private investor. The technical barriers we have, these barriers we have already discussed as a chain, value chain. So in technical barriers, renewable energy development includes the inadequate technology. Sometimes it is inadequate and lack of infrastructure. That is necessary infrastructure we do not have to implement the projects. Lack of personals. Then inadequate services and maintenance of the equipments. These are the technical barriers. Most of the renewable energy equipment in developing countries are imported from the developed nations, and therefore the lack of spare parts, adequate skills, repair services we do not have, so that these technical barriers face the again we have a socio-cultural barriers. In socio-cultural barriers, for example, household willingness, it is a very important issue. That is the many people's uh, not ready to adopt this such type of system at their home level. Then lack of knowledge and awareness of the renewable energy technology. These are the social issues I am narrating here. Then financial and economical issues. Initial cost is high. Transportation cost also high. For the wind energy case, the transportation cost is very high. Economic status and the availability of incentives. This is a very important factor. Where there is incentives and subsidy, there is a chance to increase the investment. Initial cost of the renewable energy is relatively high when compared to the conventional source of energy. Renewable energy technologies are cost disadvantages compared to the commonly used non-renewable energy technologies such as coal-fired productions. The high cost of technology therefore means that the most people are more likely to go for the co-generated energy, not for the renewable energy. So here we have to provide some policy support to the investor to to establish the renewable energy project. Then inadequate or lack of credit facility by the banks to purchase the sustainable energy technology. That's mean the renewable energy technology. They have a high interest rates. So the credit facility is not easily available, and which are at the high interest rate. So the people are lagging to install this such type of project. Their market related issues is there. So all these issues are generally interrelated with the, it is being enlaced with the value chains issues. In market related issues, the initial investment cost for the renewable energy systems are usually high. Consequently, market price for these systems remain high and unaffordable to many potential customers. Therefore, most people cannot afford the renewable energy technology because their initial investment is high. In our case, suppose we have, if we think for the rooftop solar system, definitely their cost is high, so that we never think about the installation of the such system. If there is some subsidies, incentives, definitely we will go for that. Then geographical and some ecological स्वाती मॅडम आवाज येत आहे? हॅलो. Now this slide shows the risks and risk management for the renewable investment in India. So some risk element is narrated here. That is the power prices, bankability of PPA, then contract renegotiation, power purchase, transmission infrastructure. So power prices is the important issue that has to be managed by the national level. In many cases, the power purchase agreement and their contract negotiations reflect the power generation cost, and in many the investor generally look at the in very affordable manner that the power, whatever power generated, it has to be subsidized from the government side. Then again, the land acquisition issues there, infrastructure issues there, then financing for the small scale project, these are the issues. Then transparency in asset and level risks. These are the issues which we have presented here to propagate the technology in India. That is to increase the investment in India. These are the challenges we generally facing for the renewable energy technologies into a AC grid. So challenges which we have mentioned is the power quality. Definitely, in many cases, when we are using the renewable power source, the quality the power which is generated is a lower quality. So we have to maintain this so that the people can attract toward the renewable energy. Then forecasting of power generations. In many cases, the forecasting in conventional power generations, the forecasting issues is null. But in renewable energy cases, the forecasting issue is very important. That is in future, how many power is generated there. So based on when we are considering the renewable wind energy, then the power generation is generally depends on the what kinds of wind is there available. So forecasting issue is very important. Then cost of integration to the grid, it is being the issue and challenges. Then variation of powers. Then availability of powers. Many times the renewable power projects, they do not available for the power generations. Their locations also the issues. Then speed of variations of the renewable energy output. These are the most challenges in renewable energy grid connections and their integrations. इथंच थांबतो. So now we are at the sustainable agriculture through the renewable energy. In many cases, many researchers have given their opinion how the sustainable agriculture by using renewable energy. So the primary goal of this agriculture is providing the most profitable farm income, promoting environmental stewardship, including the protecting and improving the soil quality, reducing dependence on the non-renewable sources such as fuels, minimizing adverse impact on safety, wildlife, water quality, and other environmental resources, promoting stable, prosperous farm families and communities. So in the sustainable agriculture, Reducing dependency on the non-renewable sources, this one is a very important issue, and here we have a chance to promote the renewable energy in sustainable agriculture. So enterprises for the sustainable agricultures are, so why I'm taken this, that the renewable energy have to play the important role to make the agriculture as a sustainable, and for making this, the bioenergy is the very prominent options to develop the energy system in farming. So for the agriculture farm, we have a sources of renewable energy, that is the solar, wind, hydraulic, the biomass, animal, and combined heat and power. Their technologies adoption is there. We have initially discussed this, and according to the land area which we have, that is the for the particular farm, that is small, medium, large, the range is there. What policies we have to be developed to implement such issue in our country? The policies interventions we have mentioned here. Uh, by looking toward the sustainable energy, sustainable agriculture, by using the renewable energy, the one newer concept is the clean energy farming is there. The clean energy farming explore the emerging trend in agriculture, which particular key points to improve the energy efficiency, to show the money, that is the input money, implementing farming practices that both save energy and the protect natural resources, and to produce, promote, and use the renewable energy. So these are the major issues. So what the government strategy have to be implemented in India to promote the renewable energy and to overcome the challenges, and uh, to provide the hands to propagate the renewable energy, the need to face the investment in renewable energy in by the government, so as to smooth demands for skill over the times. So there is a need to increase the skill of a particular technician, skill workers, to avoid the, that means to save the time, and there is a uh, for avoiding a patterns of booms and bust in the labor market. Then there is a need for installer of renewable energy technology to have a breadth of skill to undertake the project, requires a mix of different type of skill, either so that each can do the job by themselves. The particular needs for skill planning, here the developing countries are planning large scale renewable energy investment. So these are the strategy which government have to be taken into considerations to boost the renewable energy project in India. Thank you. Stop. Swati madam, online network. Is there any questions?
sir, am I audible?
Yes sir, थोड़ी सी जोरात बोला फक्त.
Yes, sir, you are audible. Please do.
Thank you very much, sir, for very elaborative kind of challenges in adoption of renewable energy. You have covered a lot of topics, and also creates a lot of research issues. There are some questions from my side regarding this. First one is that you use the word in value chain, the certification. So what do you mean by certification in terms of wind value chain, solar value chain, and bioenergy value chain? Is it a product example of solar energy ecosystem base? What is the kind of certification in this renewable energy?
actually, sir, these are the very innovative areas where we have to look at the chain which we have mentioned. These are the value chains generally adopted in the European countries and Americas. So, the topic which I have given today. So these are the challenges we are facing in India, that we do not have a such type of chain. So for particularly to promote the renewable energy system in India, the whatever the elements which I have taken into my presentation, that is the sub-element there, installation, operation and maintenance. For bioenergy, there is a one is growing element is there. So for the particular elements, sub-elements, the particular type of skill is required. So for to enhance the skill, to develop that skill, we have to strengthen the value chains. For strengthening the value chains, the particular manpower certifications which we needed. Sir, have you understood, sir? Deshmukh, sir.
Sir, I think hall is disconnected. So I take the next one. Yes, Deshmukh sir, are you clear with the answer?
Am I audible?
Yeah.
I think there is a problem with the connectivity. So I ask the next one. Dr. Bausa, sir, you can ask your question.
Sir, what is the government policy about the renewable energy? Whether they are going to implement or due to very high cost, they are not implementing.
Sir, we have identified policies there. So based according to the resources, we have policies. For the solar, it is being different. For wind, it is being different. For biomass, it is being different. But in wind energy, the policy they have implemented in last 10 years, it is being very friendly policy. So that investment, so that the private investment in the wind energy has been increased. So one example we have that the whatever they have been invest in the project, their depreciation they have been minus from their income tax. This is the one simplified issue. So the peoples have diverted to invest in the wind energy, and we have got the large installation in the India. So this one is the one case I have narrated. Such policies is there, but there is a need to aware for the from common people to the top investor, that how the policy is. Now we have a Kusum program is there. It is particularly for the farmers. So this is the duty of the agriculture department or the agri university, how to promote that among the farmers. But
Okay, thank you, sir.
Thank you, sir. Now I ask Dr. Rupnar, you can ask your question.
Good afternoon, sir. Hello, am I audible?
Yes, you are audible.
Good afternoon, sir. Thank you very much for your presentation and enlightening us about the potential of different RE technologies and the number of barriers in adoption of these RE technologies in India. My question is regarding the solar rooftop power plants. In our Maharashtra, new draft is proposed regarding the net metering. They are saying that instead of net metering, till now we are practicing the net metering in rooftop power plants. But what they are proposed, they are saying that instead of net metering, they are now switching it to the net billing for commercial as well as industrial power plants. So how it will affect the solar power plants, rooftop power plants installation in future? So this is my question.
net billing means the what exactly your consumption is there. Initially, it is being what the productions we have from the rooftop and what consumptions you have. So The difference is being a net. So based on that, you will get the some rebates from that. But net billing is the issue. MERC has lower the traffic. That is the rate of the the power purchase agreement, which MERC have. They have lowered the prices of photovoltaic system, and definitely it is being affect that the people have to pay, even though they have a rooftop system,
Yes, sir.
they generate the power, but it is being the the purchasing price of that power is low as compared to the traditional power, so that the people have to pay to the government or MERC or uh, electricity board. So definitely 10 to 20% variation is there. While that means if we have a 1,000 of electricity bill in 1 year, 200 rupees we have to be paid.
But
Surely.
that will adversely
Actually,
affect that will discourage discourage the industries as well as commercial.
not the industry. Actually, they are diversifying their project. Their mainly focus now is on Kusum. So large pipe plant. The government of India have focuses on the mega projects from the solar farming, particularly to the farmers. They promoting the farmers. So now government of India switched their orientation toward the farmers in relation to the by adopting the Kusum Yojana. You may go through the Kusum. You will get the details of that.
Okay, thank you, sir. Thank you.
Okay, thank you, sir. Now the question from the hall.
Yes, sir. Sir, in your presentation, you have talked about the four major elements of a value chain, which includes wind value chain, solar value chain, and bioenergy value chain. And yeah, you have talked about the certification of that. So here I want to know that what certification means regarding, is it mean a product based or is it a system based? Or is it a means ecosystem based? What kind of certification?
Certificate. Actually, this value chains is integrated with the skills. We do not have a such type of skill in India. Suppose we have a one case. Certifications means generally in our system we have a ITS system is there. Industrial Institute of Training, ITI in electrician, ITI in fitters, ITI in diesel mechanic. But there is a need to develop the ITI in bioenergy design, biomass resources handling, then forestry resources management and their utilizations, then agro residue pre-processing and management. Such type of certification courses is needed for making the renewable energy chains more effectively.
Means here certification is given for management processes, right?
Yeah.
Okay. The another question I have to ask you that
Sir,
there is word decentralized energy supply.
Yes, sir. Yes, sir. Sir, ऐकून आलो पुन्हा जरा जोरात बोला. Sir.
What do you mean by decentralized supply? You are talking about policy issues. And
decentralized means it is an independence. It is not connected to the grid. Suppose we are talking about we are saying about some biomass power project or the some photovoltaic project is there in remote locations. They are the decentralized power project, not connected to the national grid.
Okay, thank you.
Okay, sir.
Is there any other question from hall? Any other participant? Okay, so thank you, sir.
No questions from hall.
Okay, so now I request any participant from the hall to give feedback to sir's presentation.
Okay. Yes. So on behalf of all participants, I really thank to Dr. Khambalka sir for his very informative and enlightening lecture on challenges in adoption of renewable energy systems in future scenario. You have covered very in-depth sectors in the renewable energy, which covers from value chain, then different issues, policy issues, political regulatory barriers, technical barriers, social cultural barriers, financial and economic barriers, market related barriers, then certifications and institutional mechanism, right from that to the sustainable agriculture. So it is a very synoptic view of these challenges, and definitely it will help us to decide our direction for the future research in this renewable energy. Thank you very much, sir.
Thank you.
Okay, thank you, sir. Thank you, sir, for joining this session. Our participants are appreciating your presentation. Our chat box is loaded with appreciation messages for you. So once again, thank you very much. And session is over now.
Teeny madam.